Hi everyone, my name is Joseph Udias and my research project is on Candida albicans. This is more commonly known as the fungus that causes yeast infections or candidiasis. This microbe gets its name from the Latin word albicans, which means to whiten, as this yeast appears white when cultured on a plate. Candida albicans is a eukaryotic organism part of the fungi kingdom, the Ascomycota phylum, the Saccharomycetes class, the Saccharomycetales order, the Saccharomycetaceae family, and the Candida genus. Although this microbe occurs at a sporadic frequency, it does not generally cause much harm to 200,000 people who are affected by this every year. It is still important to know about, though, as it's just one of the many microbes that cause our microflora home. This fungus, whom we've developed a commensalism type of relationship with, is essential in promoting gut health, nutrient absorption, and it also aids in digestion. However, we can find ourselves with overgrowths of this opportunistic fungus as it invades epithelial and endothelial cells by active penetration and induced endocytosis. This means that people, especially those who are immunocompromised or who have issues with their gut, can sometimes find the microbe to overpopulate and cause yeast infections in our mucosa, including our urinary tract, genitals, mouth, and skin. Invasive candidiasis is when the fungus can make its way and cause infection in our blood and organs, which affects about 25,000 people each year and results in death for about 25% of those people. This infection, which can last for just a few days or up to 2 weeks, may cause itching, burning, redness, pain within the infected area, along with tiredness, fatigue, digestive issues, nail fungus, joint pain, and even a condition called oral thrush, where you develop white or yellow patches or bumps inside your mouth. Treatments for Candida-related infections would include the use of antifungal medications and changes in lifestyle, including reducing or eliminating sugar, alcohol, dairy products, and high-processed carbohydrates, along with getting better sleep, nutrition, and reducing stress. This infection-causing fungus is typically non-communicable, but if someone does come into contact via another person or hospital equipment, it's unlikely that they will develop an infection because remember, the fungus is a natural part of our bodies. However, if the same situation occurs with someone who is immunocompromised, they may develop an infection through contact, but this is still uncommon. The peer-reviewed academic journal article that I chose addresses the relationship between body temperature and how this plays a role in giving the microbe the best environment to grow and succeed through its biofilm. You can think of a biofilm as a sticky barrier that protects the communities of a microbe from attack, making it easier for them to grow and thrive. The article would experiment with several strains of 3 different types of Candida, including the one we're talking about today, Candida albicans, to see how its biofilm production is affected at different temperatures. The authors of this article chose to display the results using a whisker plot showing the amount of growth of Candida albicans measured by colony forming units per milliliter at different temperatures, including 34, 37, 40, and 41 degrees Celsius. They also used different strains of the same microbe and labeled them as CA3, CA5, CA12, and CA17. The researchers concluded that Candida albicans was more aggressive in growth and biofilm formation at 37 degrees Celsius, which happens to be our normal body temperature. The results can help us understand that this microbe has evolved to have the most success at human body temperature as indicated by the graph. Now, with that in mind, in the popular article that I have chosen, the significance of the microbe's biofilm is highlighted as one of the greatest virulence factors. According to the article, the biofilms of Candida albicans are intrinsically resistant to conventional antifungal therapeutics, the host immune system, and other environmental factors. This poses a clinical challenge to present treatments and knowledge we have of the microbe and calls for a stronger collection of research in order to combat Candida albicans and any other biofilm-associated infections. The combination of data from both of these articles proves just how harmful a seemingly harmless microbe can become in the right environments. The combination of the high success rates of biofilm production and temperatures of the human body, along with the resistance factors of the biofilm itself, can be cause for alarm, especially in those who are immunocompromised. Thank you.